One thing we can do with a derivative is approximate where a value on the curve. So this is an approximation, but we're going to use the derivative at a point. So like at A, okay, at A, the output is f of A, and the derivative, of course, would be f of A. So that's how fast we're moving at that point. So what we'll do is get a tangent line, okay, at the point, and then we're going to use that tangent line to approximate some other point, like point B, some point really close to our original point A. If we get too far away from our original point, so like point C here, then the approximation gets is worse. It's not as good. Okay, it's not as accurate. There we go. All right, so we have what we're going to do is we're basically going to write our equation in slope point form of the tangent line. Okay, so tangent line. And what we have is f prime of A is the slope, and x minus A would just be the change in x. And then, actually, I'm going to write this on the side. So f prime of A, another way to say that is that change in y over the change in x, or dy dx. And then the x minus A is the change in x. So then you see the change in x cancels, and it just gives us our how far we're moving in the y direction. So that would be this, the change in y. Okay, how far we're moving. See if I go over how far we're moving in the y direction. Okay, and then of course we have to add our f of A, so the value below the change in y. So it's like the change plus our original height. Okay, the point is A comma f of A, and the slope is f prime of A. So what we'll do is we'll use that equation, but we're going to plug in B instead. So the point B to give us the change in x is our B minus our A value. Okay. And of course, this is an approximation, so be careful there. B minus x represents the change in x, and we use the slope of A, okay? Because again, it's an approximation, it's not perfect. Okay, something to consider when we are taking an approximation using local linearization is that if the graph is increasing and concave up, so like on this side, the tangent line is below the curve. Also, if the graph is concave up and we're decreasing, the tangent line is below the curve. So if the tangent line is below the curve, it is an underestimate if the curve is concave up. So these are underestimates. Okay. If the curve is concave down, then we have an overestimate, and it's because the tangent line is above the curve. Oops, I wrote that wrong spot. Okay, because the tangent line is above the curve. So it doesn't matter if we're increasing or decreasing. If the curve is concave down, it's an overestimate. What we're estimating is the value of the curve. So if I use the tangent line to estimate, so if I go to like, I don't know, x equals negative 1.5, then on the tangent line is going to be a little bit higher than the curve. Okay, so here's how we do this. A line passes through the point 2, 5 and has a slope of 0.42. So we want to write the equation of the line at the point first. So this is my point and the slope of the curve. So the slope of the curve, this is f prime of A, and this would be my x and my y of my point. Okay, so I have y minus 5 is equal to the slope, 0.42, times x minus 2, and then we can solve for y, or that's fine. So same, it doesn't really matter which one you use, plus 5. Okay, so then we're going to see when y is equal to, what is y when x is equal to 2.3? So 2.3 is reasonably close to 2, so we're going to use the tangent line at 2 to estimate the value at 2.3. So I'm going to say y minus 5 is equal to 0.42 times our b value is 2.3 minus 2. Solve. 2 times 0.3. So our change in x is 0.3. And then what I get when I solve is 5.126. 5.126. So we estimate, I know. We estimated, so we need to change our equals to an about equals. Okay. So it's about equal to 5.126. So how much does y change when x changes by 0.3? We know that the y change is the f prime of a times b minus a. So this gives us the change in y. So that would be equal to 0.42 times 0.3, which is about 0.126. Okay, so we estimate that we are about 0.126 change from the value at x equals 2. All right, so we're going to do it again. Here we go. Use the curve, the square root of x. So to find the linearization, which means an estimate of the function at x equals 9. So first we find the tangent line at x equals 9. So I need f prime of x because I need f prime of 9. So I get, this is x to the 1/2 power. So I get 1/2 times x to the negative 1/2. And f prime of 9 is equal to 1/2 times 9 to the negative 1/2. So that's equal to 1/2 times 1 over the square root of 9. So 1/6. So f prime of 9 is 1/6. So the slope is 1/6. We'll go ahead and write our equation. We need a point. The point is at x equals 3. So f of 3 is the square root of, oops, I messed that up. I don't know why I said 3. Okay, so the point at 9 is f of 9 is equal to the square root of 9, which is 3. Yes, okay, 3. So I need these two pieces, the slope and the point. So I can write my equation and slope point. So y minus 3 is equal to the slope, which is 1/6, times x minus 9. Let's just solve for y, plus 3. Okay, so either one of these would work. Okay, now we need to approximate f of 8. 8 is pretty close to 9. Okay, so we're going to call that b. So y is about equal to 1/6 times b minus a. So 8 minus 9 plus 3. So y is about equal to 1/6 times negative 1. Yes, 8 is 1 unit away from 9, plus 3. So I get y is about equal to 17 over 6, which is about equal to 2.833. Okay, so just to compare our estimate to the actual value, in my calculator, I went ahead and took the square root of 8, and that gave me a value of 2.828. That's pretty stinking close to what we got, all right? So is our estimate, and looking at our calculator estimate and our tangent line estimate, is this an overestimate or an underestimate? So I can see that 8.833 is larger than 0.828. So I know this is going to be an overestimate, but let's use our calculus to figure this out. Okay. So I know what the curve of a square root curve looks like. It kind of looks like that. And I can tell at x equals 9 that the graph is concave down. Like the whole graph is concave down. So again, we are going to have at f double prime of 9, of 8, excuse me, of 8. We always evaluate based off of our what estimate value we're taking, okay? So f double prime of 8 is less than 0, so it's concave down. We know what I need to say is that this is an overestimate because f double prime of 8 is less than 0. Is less than 0. The graph is concave down. Is concave down. So the tangent line is above the curve. Okay, we're going to do one more. Okay, so this doesn't break it down into step by step. We kind of have to do all the steps at once. So we have to break it apart ourselves. So find the linearization of the function at x equals 1 to approximate f of 1.1 for the function f of x is equal to 3x squared plus 2. Tell whether the function is an overestimate or an underestimate, and use calculus to justify your answer. Okay, so that's a lot. So linearization, it tells me that I'm doing a tangent line approximation. Okay, at x equals 1, and then we're going to have a b value of 1.1. So I have my original function, f of x. I better figure out my point and my slope. So let's do the point first. The point of f of 1, so is 3 times 1 squared plus 2, which gives me 5. So I have a point at 1 comma 5. And then my slope would be f prime of 1. So f prime of x is equal to, power rule is 6x, and f prime of 1 would be 6. So I have a slope of 6. And then we'll get our tangent line, which is y minus 5 times the slope of 6 times x minus 1. All right, solve for y. 6 times x minus 1 plus 5. Okay. Next, we're going to do the approximation. So f of 1.1 is about equal to 6 times 1.1 minus 1 plus 5. We have a change in x of 0.1, so we have 6 times 0.1 plus 5, which gives me 5.6. So f of 1.1 is about 5. Oops, I put 5.5. Is about 5.6. Okay. So now is this an overestimate or an underestimate? Over or under? Okay. We have to figure out what the concavity is at f double prime of 1.1, or I have to figure out what the concavity is of f. So I need to take the second derivative. F double prime of x would give me, let's see, f prime of x is equal to 6x. So f double prime of x would be 6. So f double prime of 1.1 would equal 6, which is greater than 0. So we are concave up. So the graph is concave up because f double prime of 1.1 is greater than 0. The tangent line approximation is the tangent line is above the curve. So f of 1.1 is an underestimate. Whoa, I said this wrong. Because it's concave up, the tangent line is below the curve, so it's an underestimate. Okay, so again, if you have a tangent line under the curve, then your actual value will be greater than your estimated value. And that is that.